Reinforced Similarity Integration in Image-Rich Information Network. This is the title of our project. Now let's see the abstract. Nowadays, tremendous number of digital images are then existent. So there is a necessity to retrieve the similar images for an efficient image retrieval process by using two techniques. One is link-based image retrieval and another one is content-based image retrieval. So in existing system, the image retrieval will be carried out by the various factors. So the accuracy of the image retrieval process in existing system is not well good. So in order to overcome those things, we propose an efficient technique by which the image can be retrieved in the most efficient. In order to retrieve the most similar images from the image-rich environment, we implement this link-based as well as the content-based technique. In order, this image retrieval will be carried out by the annotation process of retrieving the images by means of annotating tags. The tags will contain the various factors in which the images are related. So that we can able to so that single image can be related to many images. For example, suppose if there is an images called ocean, it can be related to vacation place, everything else. So the tag will contain the every words by which the tag will contains the each and every words by which the images are related. The other retrieval technique is called the content-based image retrieval. It will be carried out by analyzing the set of regions present in the images. The regions which is analyzed by means of RBG values, that based on the color the regions will analyze. So after the analysis of regions, it will be carried out by the image segmentation. That is, the histogram values of the regions will be well gathered and maintained. After gathering the histogram values of the image, it will be processed for the distance calculation. The distance calculation will be carried out by using the Euclidean distance. So after acquiring the histogram as well as the distance value of a query image, able to compare with the images we can compare with the every images in the database. For every images, each image will be carried out the same process, that is the region analysis as well as the image segmentation. So after that, for each image we will be acquiring the histogram as well as the distance value. So we can able to compute the histogram values of the input image as well as we can able to compute the similarity between the histogram values of the input image as well as the histogram values of the images from the database. So by computing those factors, we can able to determine the most accurate image. Here the most accurate image will contains the least distance value. Based on the distance value, we can able to sort out the most accurate image as well as the similar image for the input query image. So that our proposal will by implementing these techniques, we can able to retrieve the images from the image-rich environment in a most effective way. Now let's see the data flow diagram of our project. This is the data flow diagram of our project. As I said, the image retrieval will be carried out by two methods. One is link-based image retrieval, another is content-based image retrieval. Link-based image retrieval will be carried out by the annotation process. Here the query, which means that the user need to provide the query for which the images need to be retrieved from the database. So it will be processed for annotation. Then we can able to identify the object present in the query. For that object, we can able to annotate, that is, we can able to retrieve the images from the database. So after the image retrieval, we can able to group the images by means of this annotation keyword. So after that, we can able to retrieve the group of images for the query given by the users. The next one is content-based image retrieval. As I said, first we need to analyze the region which is present in the query image. After the analysis, the region evaluation will be taking place. After the evaluation, image segmentation, that is the region segmentation, will be taking place. After that, we need to acquire the histogram values of the regions as well as we can able to compute the distance by using the Euclidean distance. So after computing the overall factors of overall factors of the query image we can be compared with the images in the database. For each image in the database will be carried out by the same process, that is the region evaluation as well as the image segmentation. So after acquiring the histogram as well as the distance value from the each image in the database, and we can able to compare those histogram values in the image comparison method. During the after comparing the query image with every image in the database, we can able to sort out the images in the database by means of distance. As I said, the most accurate image will be the least distance. The remaining appending similar images will have some little deviation in the distance. Now let's see the demo of our this is the home screen of our project. As I said, image retrieval will be carried out by two ways: link-based image retrieval as well as the content-based image retrieval. First, I am going for link-based image retrieval. As I said, here user need to provide some input query, such as here I just need to retrieve the animals image from the here I need to retrieve the animal images from the database. Here I need to provide here I need to acquire the flowers image from the database. Here I am providing. Let's proceed. During this process, the annotation process will be carried out. That is, every tags of the image will be consisting of the tag annotated word called flowers, so that we can able to cluster the images in the database by means of annotated word, so that we can able to extract the words as per the user needs. Now let's see the content based image retrieval. So for example, if I need to suppose if I need to retrieve the C images, it can be done over here. During this, the annotation process will be carried out, so that we can able to retrieve the images which is related to the keyword C. Now let's proceed with the content based image retrieval. Here the user need to provide some input query image. This is the input image for which I need to retrieve a similar image from the image rich databases. Let's proceed. These are the images that is available in our databases. Let's proceed. Here we need to create a threshold image, so that we can able to identify the object in that image. Now, during this retrieval process, the calculation of the histogram as well as the calculation of the distance, calculation of the histogram as well as the calculation of the Euclidean distance will be carried out. After calculating those histogram values as well as the Euclidean distance, then the image input query image values will be compared with the each images in the database. That is, the comparison between the histogram will be taking place. Then this is the most accurate image for the input query image. This list will be sorted out by means of the distance. These are the most accurate as well as most similar image for the input query image. Now let's see the graph. This graph shows that this graph represents the timing by which the images is compared with the input query image. So by our proposed system, we can able to retrieve the images from the image rich environment in a most effective way, so that we can able to reduce the processing time. Thank you.